Thank you very much. All right. All right. Thank you, everyone, for your patience. I apologize that we had a little bit of an IT issue. Those of us, we love astronomy, but we hate computers. I would like to invite Mr. Eric Fischer to come up, and he will be giving his presentation on astro.
The Griffin, Flip, and Volt, not a law firm.
Okay.
Okay. Let's
right.
button the right course.
So actually just tell him, how about this? You stand over here and I will press the buttons for you. How about that?
All right.
We'll make this and just watch the cord over here.
Don't have another ITX.
Yeah. All right.
Okay, everybody, can everybody hear me out there in the world?
Yes.
Okay. Before I get started, you know how you press your button for the little hands to go clapping? I'd like you to do that for several members online. For some of the younger members, we have some of our elder statesmen, emphasis on elder. Wade Barbin, who joined the club in 1962 when I was 12 years old. Eric Bauer, I think you joined in 1970. Dave Penson-Stadler, I think you were in the 1970s. We have some very senior members. That's the word, senior, not elder. So just welcome.
1964.
64, good. And Kristen's going to be my button pusher. Okay. Okay, I talked almost exactly 2 years ago about the company called Astrobotic on the north side of Pittsburgh, about a mission called Peregrine. It was a first attempt of the companies to send a rover to the moon. A lander was a rover on board, and it failed. About 4 hours into flight, it sprung a fuel leak for a very ridiculous reason, a problem that could have been solved. So anyway, Astrobotic licked their wounds, learned their mistakes, are now attempting a second landing on the moon with a different lander, much bigger, called Griffin. So the talk tonight is about the Griffin lander, about a new payload on the back of our lander that we're delivering called Flip, and then a future payload on Griffin called Volt, okay? So next slide, please. Okay. Before I get into the meat of the subject, I got a couple pledges to you. No scientific graphs or charts tonight. And go ahead. And no equations. This is all pictorial, okay? Not that there's anything wrong with graphs and equations, but we need a break from those from time to time. Okay, press on. Oops, it jumped up a bunch.
Oh, did it?
It jumped 5 before.
Oh, that was the next one, bud.
Oh, well, that's strange. Anyway, whatever shows up, I hope it's the right order.
Okay.
Oh, gosh. Yeah. Yeah, this is slide number 4. Okay, anyway. Astrobotic technology on the north side, just between it's sandwiched between the restaurants that make sandwiches just up from the Steelers Stadium. In 2005 or 6, Google offered $30 million to any small private high-tech company to land something on the moon. Boeing and Lockheed were not eligible for that prize, $30 million. So about 20 companies were formed around the United States in pursuit of the prize. At that time, the thought was, hey, we win this $30 million prize. There's 10 or 15 of us. We split the money, and then we enjoy the rest of life. Among those 20 companies was Astrobotic, graduates of CMU's Robotics Institute, which, by the way, is one of the best in the world. Well, guess what? The prize fizzled. In 2018, Google says, you guys can't do it. We're pulling the prize. But an idea had been born, the idea that private companies could do the routine launching and landing services, take that away from NASA. The technology is mature enough now that we can farm it out. NASA's watching this whole Google prize and said, it's time to start farming out these routine services to private companies and save a lot of money in the process, okay? And Astrobotic started out in a small garage in Lawrenceville, and now they have almost 300 people. They're hurting right now because that first failure caused some problems for them. Our hopes are riding on the Griffin lander. Next slide, please. Okay. Think of Pittsburgh working environment 100 years ago. You're probably in a mill. You're probably breathing noxious gases and soot and whatever, particulates. And now we have the exact opposite. We have hospital operating rooms, and in Astrobotic's case, clean rooms for building spacecraft. To appreciate how dirty the air is that you breathe, next time the sun comes in a window and there's a nice angelic sheet of sunlight, and there's you look at it and you see dust particles in the sunlight. Or next time you're in a movie theater, look back at the beam from the projector, dust particles. For every one of those particles you see, there's a bunch you can't see. Dirty air, that we all breathe relatively dirty air, but not in the clean rooms at Astrobotic, okay? Okay, so the previous mission for Griffin lander, the second lander, was to deliver a rover from NASA called Viper, Volatiles Investigating Polar Exploration Rover. I got it right. How about that? $90 million rover. But we found out later that NASA was real nervous about putting their high-priced rover on our second spaceship. I'm saying R like Astrobotic. I don't actually work for them. So, next slide. They canceled the rover. It was already built, already tested down in Houston. The official reason was, well, we ran out of operating budget. The real reason, the scuttlebutt, is because they just didn't trust Astrobotic to take this high-value rover to the moon. So for a while, Griffin was going to go to the moon with nothing on its back, no payload, okay? So now we have a new customer on board, which I'll tell you about, the Flip rover from a private company called Astrolab. And it's kind of like what the Viper mission was. We're going to deliver a lander touchdown near the South Pole, a region called Nobile, and the rover will drive off and do some experiments. That's our mission. So it's similar to Viper, but it's not a NASA payload, it's a private payload, okay? Griffin, if you know your Greek mythology, it's a mashup of an eagle and a lion, the body of a lion and the head of an eagle. It's supposed to symbolize strength and power and so forth. So I didn't know that until now. So it can't happen in nature. You can't mix a lion with an eagle, okay? Okay, go ahead. So now we're going to just do a quick review of all the vehicles involved with this mission called Griffin 1. It's called Griffin 1 version 2.0, okay? Go ahead. Now, I'm not going to walk you through all the callouts on this diagram, but I want to draw a couple of things to your attention. The thing on top with the two wheels is the Flip rover, which I'll show you more of later. This moon lander is built, the pieces, the metal brackets and braces are built locally. We found a company up in New Kensington, or no, Tarentum, no, Katanning, wrong town. Little hole in the wall company called Edgar Industries. Rickety old building, but they had a super accurate milling machine. So we got all the pieces, the structural pieces for the lander at a tiny fraction of what Boeing or Lockheed would charge, okay? On the bottom, you'll see several main engines. There's 5 main engines and 18 thrusters. And that's with the big engines are for landing and the thrusters are for maneuvering in space. Go ahead. Here's the neat thing about this lander. It's good and bad. We run on what are called hypergolic fuels. Now, very simply, a hypergolic fuel system is an oxidizer and a propellant. All you have to do is touch, and you've got your exhaust. You don't need a spark. Hypergolics store real well over long periods of time, unlike the cryogenic fuels, which boil off. The one problem with the hypergolic fuels is that they're toxic, really toxic. One of the engineers at Astrobotic told me that if you're in a room and you get a good whiff of hypergolic fuel, you're probably dead in about a minute. That means it's gotten into your lungs. So they're trying to find a fuel that stores for a long period of time, but is not toxic. Go ahead. Okay, this is just a top view of the lander. You'll notice some things that look like they're sort of orangey. There's 3 cylinders, and then if you look real carefully, you'll see 4 spheres. These are fuel tanks and helium tanks made not of metal, but of carbon fibers for super lightweight, weight-saving purposes. I'm told by the people at Astrobotic that, for example, the fuel tanks are 3 foot across. The official name of the material is composite overwrap pressure vessel, which just means carbon fibers. They're so lightweight that you could hold it in your hands and throw it to your friend like a beach ball. Weight savings. You might have seen this material in the news a couple years ago with the submersible that was lost and going down to the Titanic. They used composite materials, but they didn't use enough, and it imploded and killed everybody instantly. So really neat feature of the lander. You'll see the thrusters around the edges and the landing gear. Okay, let's move on to the next one, please. Here's a side view of the lander showing the solar panels. Now, if you look in the upper right, you'll see that it's an octagonal design of the spacecraft, 8 sides, but only 5 of those sides have solar panels because the other 3 sides are needed for radiators. Any kind of spaceship generates heat and electrons, so you have to shed that into space. So what that means is when this lander touches down, those solar panels better be facing the sun or the spacecraft will go dead. Okay, next slide. A couple months ago, the solar panels were installed. We said, yay, we're making progress. We're building the spaceship. And about 3 days after they put them on, they took them off. And what we've learned is that in the space business, you put something on for what's called a fit check to make it sure it fits, then you take it off and put something else on. So the spacecraft is not fully assembled right now. By the way, going back to those fuel tanks, they have not arrived from the supplier. They're 5 months late, so we're probably not going to fly until March now. Okay, next slide. Here's our payload. It's called FLIP, and I'll tell you about the acronym later. It's a rover from a company called Astrolab, which is based in Hawthorne, California, and I think they have their home office in Switzerland. You'll notice that this thing has very large wheels. In the past, the Martian rovers, the lunar rovers had little wheels, maybe 6 inches in diameter, maybe 8 inches. And when you were traveling across the moon's surface, you had to dodge left and right and left and right to avoid rocks, divots, gullies, craters. These new hyper-deformable wheels go right over them very smoothly. And the idea is that we don't have to do zigzag motion. We can just travel over the moon with great comfort and no vibrations. Next slide. By the way, just a week ago, they changed the design of the FLIP rover. The one on the side, on the left side is what I'm going to show tonight, but it actually is the new design is on the right. The one on the left kind of looks like a flip phone, but now the solar panel pops up on the long length of the spacecraft. So keep that in mind that I'm showing you the old design of the FLIP rover, okay? Close-up of the wheels. This does not have spokes. It has a system of cables that talk to each other. I will stretch and you will bend. You will stretch and I will bend to absorb shocks and motions and impacts from craters in the ground and so forth, okay? No more dodging small rocks. Now, obviously, if we come up to a big rock, we have to go around it. Next slide. Okay, if this design works, Astrolab will then propose to NASA a people mover, a larger version to carry 2 astronauts with these super smooth riding wheels. That contract has not been let. Obviously, this test has to go well. Next slide. What's a great place to test it? Pittsburgh. Okay. Yes, we all have pothole memory. We know that the end of 2nd Avenue, there's one on the right side, and the end of 4th Avenue is one over here. There are tire companies that are looking at these hyper-deformable wheels and putting them on cars someday. Probably not many years yet. The day may come.
What that is.
Yeah. The day may come when you have no air pressure. You have these wheels that give way. Okay. Next slide.
Tire companies will go out of business.
Yeah. In addition to the FLIP rover, which is very large, we're carrying a very small rover called a cube rover. I've got a ruler on the bottom for a sense of scale. Think of it as a shoebox with 4 wheels. That's all the bigger it is. This is Astrobotics. What's the word I'm looking for? It's a registered design. It's a patented design, okay? The idea in the future is that instead of sending one big rover out onto the moon's surface to do science, you'll send a whole lot of these little ones. And each one of these cube rovers will do a different task. One might measure radiation. One might measure outgassing. One might measure solar flux, divide the load. So if you lose one of those rovers, you haven't lost your whole mission. Again, I'm not going to walk you through all these callouts here, but I do want to draw your attention to the solar panel. You notice that it's sideways on this rover, just as it was on the Griffin. That's because we're going to be doing 90% of our work at the south pole of the moon. At the south pole of the moon, the sun hugs the horizon, never gets very high in the sky, so we have to get our sunlight sideways to make electricity. And there's some implications to that later. So I'll show you how this cube rover gets delivered. So think of Griffin as having the big flip rover and the small cube rover. Go ahead. The other payload, the European Space Agency is putting a thing called LandCam X. It's basically a very exotic digital camera with electronics for the Europeans when they start landing on the moon so that they can zoom in on a landing site and target their lander. Next slide. Laser reflector. You remember from your high school physics. Angle of incidence, angle of reflection. With laser reflectors, the light beam that you send goes right back at you. It goes right back at the emitter. The Apollo astronauts left some on the moon. We're going to leave this on Griffin, and the idea is that someday some lunar orbiter will fire this down there and find exactly where Griffin touched down. A laser ranging retroreflector. So quite interesting technology. There's corner cube prisms, and somehow the light goes right back at you. So, okay, next slide. What the heck is this? We are carrying, there's a new technology out here called nanofish. Remember microfish? Those old timers would go to the library and run microfilms to look at old newspapers. Now there's nanofish. Each of these is about halfway between a nickel and quarter in size. One of these alone could carry the entire Wikipedia in English. Imagine how many gigabytes. I think the rating is 1,000 document pages, 200,000 DPI of images, 200 gigabytes of digital data on just one of these things. So we're taking it along as kind of a symbolic thing. It has no scientific value. Okay, quite remarkable. Look it up sometime, nanofish technology. Okay. Ready to go? We're riding on the Falcon Heavy rocket. Right now, operationally, the most powerful rocket, soon to be replaced with other ones that are even more powerful. You can see in the upper right, it's almost as tall as the Statue of Liberty. It has 27 engines on the first stage. And, I was talking about propellants earlier. This one runs on good old kerosene, what's called RP1. But to get more punch out of the engines, SpaceX densified the liquid oxygen. They took it down to its liquefaction point, then went colder. So it's a very, very potent rocket. What we like is it's a very proven rocket. We're going on a rocket that's been flown many times very reliably. Okay. Next slide. So now we're going to go through the mission profile. And why don't I just tap it to myself? So it's bothering you.
Oh, you're not bothering me.
Anyway, first thing we got to do is attach the flip rover up there on that gantry down onto the lander, okay? Then we put it inside what used to be called the nose cone. Now, in proper parlance, you don't put it in the nose cone, you encapsulate it in the fairing. The fairing is two large clamshells that separate from each other to send out the spacecraft. As you can see in this picture, we are not taking up much space in that clamshell. Much bigger spacecraft can be carried in there. We're just a little, like a hood ornament in there as far as size is concerned. Okay? Go ahead. Then we roll out to the launch pad. I'm sure some of you have seen the sequence. Elon Musk rolls his rockets horizontally and sets them up vertically. What's neat about this flight is we're flying from pad 39A. If any of you know anything about the launch pads, that's the same launch pad that Neil Armstrong and all the Apollo astronauts, except for Apollo 10, took off from. So there's certain poetic justice. We're going to the moon from the first moon launching pad. Okay, we're going to fly the mission now. Liftoff of a Falcon Heavy. Make sure to get down to Cape Canaveral for one of these launches. Your ears will be ringing and it'll be quite a sight, okay? So as we fly up through the atmosphere of the Earth, of course, the Earth's atmosphere gets denser closer to the surface. So we have to fire all 27 engines to get out of the densest parts of the atmosphere. Next slide. The side boosters use up their fuel and fall back. But they don't just fall in the ocean. You've seen this on YouTube and other places. They come back and land. This is where Elon Musk is saving a lot of money by reusing his boosters. And to see them, two of them landing at the same time is quite a sight. Go on YouTube for that. So anyway, the core stage presses on. Go ahead. And then it falls away. But you can't see the core stage landing because it has to happen out over the ocean. So you've got a barge out in the ocean about as big as a baseball field, pitching and dodging in the waves, and somehow he manages to land that core stage on the barge. Again, it's just remarkable technology. So the upper stage with our payload keeps firing. Go ahead. Remember the fairing I was telling you about? It's time to get rid of it. It has pyrotechnics, little explosive charges. It flies off. And there's our little Griffin lander exposed to space for the first time. We're going to find out if all that testing paid off. Does it react to cold and heat and vacuum? Go ahead. So here's what we do. By the way, that blob over on the right, I'm going to tell you about. I'm going to keep it as a kind of a secret right now. So anyway, we're going to fly partway around the Earth, make sure the spacecraft is good, make sure all the systems are working, and then press again. We fire the engines for translunar injection, a famous term from the Apollo era. Now we're on our way to the moon. We cannot come back to Earth. Go ahead. We get up there. Now Griffin is on its own. It separates from the Falcon Heavy. Getting my names mixed up. It separates and now it's truly on its own. Okay. While it's floating in space, it has a device called a star tracker, which would be interesting to the astronomy community. It's got a camera who tracks one of 27 first and second magnitude stars to lock its position in space. Say, I see Arcturus over there. I'm going to lock on that. Now I know where the moon and the sun and the earth are. It's called a star tracker. It's kind of like a sextant in a general way, if you see that in the lower right. Now we hit the blob. What is the blob? It's the Van Allen radiation belts. If you guys know your space history, Explorer 1, the first US satellite, accidentally found the Van Allen radiation belts. It's a donut-shaped charged field around the Earth. In the next slide, just to show you what it looks like. This is a nervous moment because the spacecraft's going through a field of high-intensity radiation, and the electronics have to be hardened to withstand these charged particles. Otherwise, we can have a problem. Astronauts have to also pass through this, but they have lots of protection. Once we get past the Van Allen radiation belts, now the moon's gravity is pulling us and we're gaining speed. We were slowing down as we went out, and now we gain speed, and we're screaming into the moon at 3,000 miles an hour. We've got to go into orbit around the moon, and we're not going to land. But here's what's interesting. Keep next slide. We don't go into a circular orbit, we go into an elliptical orbit, and there's a reason for that. Next slide. You do all your maneuvers well, on Earth it'd be apogee. I forget what the lunar term is, apollune. You save a boatload of fuel by doing that. It's one of the advantages of orbital mechanics. If you do your maneuvers way out at the far point of your orbit, you save a lot of fuel. We're trying to preserve fuel. So anyway, we fire the engines, and then we shrink ourselves down from a very egg-shaped orbit to a circular orbit. Then we loiter for a couple of days, and all the systems on the lander are tested and checked out. Make sure before we fire the engines and start falling towards the moon. Next slide. So we go to the moon in 3 burns. The first is called the deorbit burn. We fire the engines, it starts falling towards the ground. If we don't do anything, it'll crash. It's going to start descending. Okay? Shut down the engines. We're falling, getting closer to the moon. Then we fire them again. Next slide. Close to the moon, and we start our landing approach. Interesting thing about how Astrobotic does this. Next slide. It has something called terrain relative navigation. This was tried on the Mars missions. There's a picture of the landing site on the onboard computer, and then there's a camera called Opal that'll look and try to match up what it sees with the picture that's stored in the computer. When they line up, you see here the blue one and the gray one match up. We're on target. That means we're now within 1,000 feet of the landing site after a distance of 250,000 miles. It gets better. Okay. As we get closer to the surface, we start firing lasers, LiDAR, the light version of radar, firing laser beams at the surface to gauge how fast we're coming down. Are we going too fast, too slow? What's our angle of orientation to the ground? And that's interesting because you don't think of the moon as a very reflective surface, but somehow these laser beams, they can tell how far down they're shooting and what the angles are. And again, remember, the speed of light is what, 186,300 miles per second, and it's calculating distances like in 100 feet using laser beams. Amazing technology. Okay, now it gets dicey. We get close. We learned this problem the hard way. As we get close to the moon's surface, rocks and dust start kicking up. They found this in Apollo. They found this in some of the Mars missions. What happens is there's no atmosphere, so the dust is easily blown away, small bits of rock. And some of those small bits of rock ricochet off of other rock and come back at the spacecraft. It's quite possible that the spacecraft could be damaged during the final moments of landing. And if you go to the next slide, please. It happened on Mars Curiosity. Look at the deck of the lander. See all the bits of rock? Fortunately, those bits of rock didn't do any damage to the Curiosity rover, but we learned a harsh lesson that landing is not just fire the engines, land, and shut off the engines, that these rocks flying back can be a problem. Okay. So now we have touchdown in the moon's noble, I'm going to call it nobly, that's what I heard, region. And everybody in mission control jumps up and hugs and high fives and so forth, and then we go to work. First thing to do is to turn on the rover. It has a headlight, it has hazard cameras, and the rover has to talk to the rover, Flip rover, which is owned by Astrolab, has to talk to its mission control. So they talk through Astrobotic to check out its systems. Then we're ready for deployment, a new way of deploying on the moon. Ready to go? Okay, there's a winch cable. Instead of just driving off, we're going to lower it down with a winch. So again, flat headlights on, and we're going to slowly lower it to the moon's surface. You can just step through these a couple of slides and, bang, bang, bang. Going down, wheel touches the ground, levels off, and then the cable is separated. Now the flip rover is on its own. Next slide. It has to turn on it's got to get, it's running on a battery. So that solar panel has to flip up vertically to start collecting sunlight. Then it starts on its merry way across the moon's surface, checking the hyperdeformable wheels that I told you about. Also, a new method of insulating the electronics. The problem is on the moon, if you're on the moon for like 3 or 4 days, the battery is minus 200 degrees. Everything freezes. So they've got this super insulating material that they claim will hold enough heat in here until the sun comes up in the electronic package, so it'll keep operating. And this is not a problem for NASA. They put nuclear batteries on their spacecraft to keep them warm, but the private companies are not allowed to handle those kind of batteries. It's also going to be testing some coatings that block lunar dust. Lunar dust is very like talcum powder. It'll get into everything, okay? Now, can you see flip there? What happens where we're landed? We're in daylight. Uh-oh, now we're in shadow. But I said this is near the South Pole. The sun is always up. But the South Pole has mountains and craters that cast shadows. So there's going to be periods of time where it has to survive at minus 200 until the sun comes back up. This is actual footage from Lunar Reconnaissance Orbiter. Okay, next slide. So when that happens, it hunkers down. That solar panel goes down to act like an insulator. The spacecraft stops and it hibernates. It hibernates. On the left here, see it there? I'm waiting for the sun to come back up. On the right screen there, the sun's back up. We open up the solar panel and we're back on our merry way. This is what makes or breaks this mission for Astrolab. That thing has got to wake itself up when the sun comes up and keep going. If it doesn't, that means that they have failed their test, their insulation test. So anyway, we're going to go now to the little cube rover I described before, the shoebox with 4 wheels. It's going to be lowered with its own little winch. Again, think of this as very small, on the side of the spacecraft, and it'll drive off and do some steering tests and traction tests, and hopefully turn around and take a picture of the lander. That's what we're hoping. Okay. Okay, so let's say the Griffin mission works. We're all happy with the lander. Now we want the phone to start ringing for customers, but we already have a payload plan for Griffin 2. If Griffin 1 doesn't crash, we have a payload for Griffin 2 called VOLT, all right? And we're going to get into acronym heaven here in a minute, okay? Okay. Here's the problem. We're going to have moon bases on the moon, charging stations for rovers, science instruments, communications networks. Where do we get our power? Of course, on the moon, there's no natural gas, there's no coal, there's no oil, there's no geothermal, no nuclear so far, although that's being thought about. The obvious choice for power on the moon is solar power, okay? So what Astrobotic has come up with is called VOLT. Now, VOLT stands for VSAT, Optimized for Lunar Traverse, and VSAT is for Vertical Solar Array Technology. You know the space industry loves their acronyms. The design of the array is what's called a rollout solar array, ROSA. These are on the space station. The technology's already been proven. So we're going to we're going to drive our rover. You can see it's very big with that scale there in the lower left. We're going to drive out of the lunar countryside and stop, put the brakes on, and here's what happens next. Next slide. Ready to go? There's an astronaut for scale. Up it goes. Just unravels itself vertically. Keep going. 60 foot into the sky, and this is the short version. It'll generate 10 kilowatts of power. Now, I'm not a power expert, but that's a lot, okay, for something this size, okay? There's the one on the left is the one I just showed you. There's the big one called VSAT XL, extra large. And it's, I can't read the number, 34 meters, whatever that translates to in feet, okay? Very efficient for power generations. Okay, next slide. The solar panel, these arrays that have reached up into the sky rotate to follow the sun. They're 140% more efficient than solar arrays on the ground, on Earth, because there's no atmosphere. You're getting pure sunlight. They only have a service life of about 10 years. Why? Because micrometeorites are going to eat them alive. They're going to be degraded by these little impacts. So about 9.5 years, you're going to start to see the power output go down. They're done. It's space junk sitting on the moon's surface. Okay. So now for some intriguing possibilities about this VOLT rover. Go ahead. Oh, by the way, I forgot this thing right here. Can you see in the picture that you got your solar panels, but how do you get the power from them to your moon base? They're going to lay extension cords on the moon surface. On Earth, of course, you can't do that. All utility companies, you've got to be underground, on a pole or on a tower. There's nobody on the moon. So in due course, you're going to have all these solar panels, not only Astrobotics, but other companies, and extension cords laying all over the lunar surface. We're going to get the extension cord from the solar array to the base by way of another cube rover. It'll just reel it out. So, but now here's what I hope is intriguing for you. Could we see these solar arrays, not just from Astrobotic, from other companies here from Earth, okay? So what I want you to do is think back to, go ahead, Iridium satellites. I'm sure most of you saw the Iridium flares. The Iridium satellite was called a gravity gradient satellite. In other words, it always kept a certain orientation, and it had 3 panels, about 3 foot wide and about 6 long, a little bit smaller than the door in your house, but they were polished like a mirror. And at just the right sun angle, you'd get a flare in the sky lasting a couple of seconds going, and some of our club members say -7 magnitude, that's what brighter than Venus, okay? So the question is, next slide, could we see the VSAT solar arrays flaring the way we saw the Iridium satellites? Now, the Iridium satellites were a couple hundred miles away, 300, 400 miles away, even at a slant range. But these VSAT arrays are much larger. So it all depends on the reflectivity of the solar material, the solar cells. If it's not reflective, we're not going to see them. But if they do reflect sunlight like the old Iridiums, it's quite possible someday at a star party, we'll see little stars along the edge of the moon. Solar panels, proving that we are there, by the way, for any skeptics, these solar panels reflecting sunlight. The problem comes in, of course, this can only happen during full moon. Of course, your eyes are going to be affected by the bright moonlight. And the analogy I would use is the recent Titan transit of Saturn. When Titan got close to Saturn, it was not anywhere as bright as it was when it's way out. Because your eyes, I guess, what's the right word? Stop down, because you're getting the glare of Saturn, so Titan looks dimmer. Same thing could happen here. The glare of the moon could make these flares dimmer. So maybe an occulting bar. We could make an occulting bar to block off the moon except for the limb. Or just move the telescope so that the limb of the moon is at the bottom of the field of view, and fingers crossed, maybe we'll see one of these solar panels reflecting light back to Earth. It would be quite a sight. And with that, I think that's my last slide. Thank you, everybody. And any questions out there? There's a test on Monday in your email. Any questions? Thank you, Tiger.
Yeah. Hey, Fish. What level clean room do they use at
10K, 10K. You know what that means?
10K, okay. Yeah, I know what that means. That's not very clean. I worked at Seagate for a while in a class 10.
Right. Yeah, that's with the chips in the chip factories in Taiwan. I think they're class 10. 10K, all that means is a cubic meter of air, roughly a cubic yard, has at most 10,000 microscopic particles, which sounds like a lot. Right here in the Haddad Theater, it's 100 million particles per cubic meter, microscopic. So it's dang clean, okay?
Yeah.
It looks like Joe has his hand up.
Joe Mulqueen. Are you muted?
All right, maybe.
Yeah, okay.
I think in the chat, let me just come over for a minute.
By the way, Joe, if you hear me, I've got your scan-on room key tomorrow.
All right, Patrick, what will happen if the rovers start to run over the extension cords?
That is a very good question. That's a very good question. These are, on the moon, they're only going to weigh 1/6. You ever pull your extension cord in your backyard, and the longer you pull it, the heavier it gets? Well, on the moon, these things are really lightweight. They have special material to prevent abrasion. I would imagine that somebody would manage that, make sure you don't run over the cords. But any other questions? Again, fingers crossed that we might see these solar arrays someday. That would be quite exciting. that it? Thank you, everybody, for your attention. And back to business.
Oh.
Wait a minute, Eric Bauer.
Good, Eric.
Sorry, that was a mistake.
Oh, gee, Eric, you asked the best questions. I had my hopes up. Make up a question. Okay,
All right, just be careful.
yep.
All right.
Talk about not tripping over extension cords.
Yeah, I
right?
know.
Okay.
Oh, careful. It's okay. It's okay. You're fine.
Astrobotic on the north side, just up from the Steelers Stadium. You can see this stuff happening in real time. Okay, thanks, everybody.
Thank you.
Oh, hey,
Thank you,
hey,
Eric.
Fish,
Oh.
did I see you in that picture of the Astrobotics group?
No.
No,
It's all
there was a guy with a ball cap on about 2-3 rows back. I thought it might have been you.
Okay. Here's what I'm going to tell you about the astrobotic guys. Okay, can you all hear me? These are rocket scientists, literally. And I've studied the subject my whole life. And I talked to them and I found out how much I don't know.
Hmm.
They're brilliant. Their understanding of spacecraft technology and navigation and propulsion is mind-boggling. This is a very select group of people. And we have a lot of international engineers, Portugal, Venezuela, Chad, engineers from all around the world, not just CMU. Okay. No, I was not in that group picture. Good question. All right.
All right. Thank you again, Eric. Very nice presentation. All righty. So if you guys want, we could do like a couple minute break. That way, if anybody needs to get up and stretch, use the restroom, then we'll go ahead and start the meeting. I am not going to try to use a PowerPoint tonight just because I'm kind of over this at this point. I apologize, but we will continue to have the meeting tonight. So if you guys want to take a break and stretch, for those that are on YouTube, if we will be back here shortly and we will continue with our general meeting. Thank you, everybody. So it is 8:39 PM on October 10th, 2025, and I'm going to go ahead and call this general meeting of the 3AP to order. John, were you good to go? Okay, sorry, I forgot to ask you. All right, Rich, would you like to come up here so they can hear you? Rich is going to read the minutes from our last meeting, which I believe was on September 12th. Have at it, Rich.
Meeting minutes from September 12th, 2025. General meeting called to order at 7:30 with a presentation by Alex McConaughey, titled Alf's Peculiarities. The business portion of the meeting was called to order by Kristen at 8:31 PM. The minutes of the May general business meeting were read by Rich Dawlish. Lish Bartoluzzi made the motion to approve the minutes as read, seconded by Brian Crawford. The motion was unanimously approved. John Holtz gave his look at that presentation on upcoming events for September and October. Highlights included Moon, Venus, and Regulus making a triangle the morning of September 19th. Final chances to see Titan shadow transit across Saturn for this cycle on September 20th and October 6th. Saturn and Neptune oppositions on September 20th and 23rd respectively. Officer reports. Kristen Crawford had nothing to report from the president's position. John Wenskevich reported that Eric Fischer will be the speaker for September 2025, or I'm sorry, October 2025. January 26 and March 26 meetings are currently open. If any members would like to present at one of the 2026 meetings, please reach out to John. Nothing to report from the recording secretary office. Lish has seen a reduction in spam emails. Also, there has been an increase in the 3AP social media presence with an increase in shares and cross posts of 3AP events and general informational posts. Gail Reiger had nothing new other than 23 new members since the May 25th meeting. Treasurer was not present. IT committee was not present. Joyce Osborne Fisher was not present. Eric Fisher passed on that due to the growth of the Guide Star, it will continue to be split into two segments, one for the articles and one for the astrophotography images. Joyce is trying to keep the file size below 10 megabytes. Kristen presented the slide listing the names of the 23 new members to be voted on by the members. Mike Miller made the motion to accept the new members. John Diller seconded the motion. The motion passed unanimously. Total members are 434, 5 fewer than September 2024. Observatory reports. Eric Fisher reported that the September parties are on the 13th and 27th. Wagman renovations are really progressing. Both telescope bays have been recarpeted and repainted. The reception room will be painted soon. The new gravel for the driveway was dumped and spread, with a special shout out to Brian and Kristen Crawford for bringing their tractor to do the bulk of the spreading. He also thanked his associate directors and committee for all the work they've been doing. Final plan project is the new drainage trench on the north end of the building. Also, they are starting to lay out plans for training on the telescopes. Brian Crawford reported a successful star party season so far at Mingo, with 5 left for the season. Mingo also had carpet replaced in the telescope bays and a very successful 20-year anniversary celebration. Brian also reported that the loaner program now has 4 smart scopes available, 1 C-Star S30 and 3 Dwarf 3s. During the Star Party season, loans will go from one Star Party weekend to the next. It encourages participation at the events, and help is available for questions and instructions. He is also trying to put together a loaner AP rig. A mount and ZWO camera are still needed. New business, the astrophotography contest is coming up in November, and there was a debate at the meeting continuing on the list server about new additional categories for smart scopes. The November meeting will be hybrid, the in-person event at the Allegheny Observatory. The holiday party will be December 12th at the Buffalo Inn in South Park, PA, and again be potluck. John Stump reported that he will be updating the rules and permissions on the Discord server. You may need to add a rule to see the specific channel, for example, astrophotographer. The club's YouTube channel will also be linked, so new videos will trigger an announcement. Moderators and admins are needed. If interested, contact John. The Allegheny Observatory Open House was September 26th. Spaceberg was October 4th, also at Allegheny Observatory. I am scheduling a VA Star Party for the 3rd anniversary of the VA Observatory dedication, and that will be this Tuesday, October 14th. No old business was discussed. Motion to adjourn the meeting at 9:24 was made by Marcus Mueller and seconded by Patrick Rigger. Motion passed unanimously. Next meeting is tonight. That's it.
Thank you. All right. By the room or online, may I get a motion to accept the general meeting minutes from September 12th to 2025? Patrick, if you have your hand up. May I have a second? Oh, I don't know if Eric or.
Eric Fischer just raised.
Joyce and Eric. Okay, we'll just take the double, right? All right, all those in favor, thumbs up. Aye.
Good job.
All right, any objections? Any abstains? All right, motion passes. All right, thank you, everybody. All right, so next order of business, John, did you have anything for look at that or look at this for today's meeting? Oh, John.
Yes, I
oh,
do.
there we
I
go.
have some slides. I'll go ahead. I'll share my screen.
Yeah, you should be fine.
Can you hear me okay?
Yeah.
Well,
I think there's-
no,
Yeah, there's a delay with your
My internet.
camera. Yeah.
that is not very good.
So maybe I spoke
So-
too soon. Do you want us to come back to you to see if it fixes itself?
Come on, which? Okay, it may just be like,
Yeah, you're still breaking up in and out. Yeah.
no, it will just
Oh, there you go.
unfortunately be what it will be. Or, yeah, if you want to come back, that's fine. I'll move to a different room.
Okay.
Yeah, let me go down to a different room, so come back to me in a minute.
Okay. Sounds good. All right. Okay. So let's go ahead and so we do have new members from this month. I had, so Gail was nice enough to text me their names. Jim Yalsko, Lucas Waldrop, Antonio Zalaga, Anita Sharma, Peter Urban, Jonathan, I'm not sure how to say his last name, but it's O-N-G, Ong, Michael Fair, Lynn Wheatcraft, Neil Wheatcraft, Jillian Cinco, Tim Paluca, Emily Von Worth, Jim Yosko, and Anita, I'm sorry, those were her typos on this. Okay, got it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 12 new members listed. All right, to the best of my ability. May I get a motion to accept these members into our lovely organization? Tom, it looks like you raised your hand. May I get a second? All right, Mary Devon, second in the motion. All those in favor, thumbs up, aye. Mhm. All right, any objections? Any abstains? All righty, motion passes. Thank you very much, everybody. I don't know the full number. Rich, you and I were just recently talking about that. Were we getting close back up to 500 again? It was close.
It was close, it was in, I want to say 470s.
That's what I thought. I think we may have climbed back up to the 470s for membership, which is pretty good. You know, we're getting close to the end of the year, so, you know, make sure you remind everyone that it's time to get your club memberships in or renewals. Yep, ka-ching, John. But anyway, so just as a reminder, if you have any questions, feel free to reach out to Gail. And, you know, if there's anything about your membership, if there's anybody that you know of that's on the fence about joining, remember that the club for a new member has that extension. So if they join now, it would be good until December of 2026. So, you know, just keep that in mind. You know, suggested as a nice Christmas present with a nice Sea-Star telescope under the Christmas tree. So, but yeah, so just keep that in mind. All right, John, I see you were back on. Would you, or do you think you're good to go?
Yes, it can't get any better than this, so.
Okay. All righty. So, John, go ahead.
Okay, can you hear me?
Yes.
And you can see the
Yep, we can
screen.
hear you.
Let me see if I can hide that. All right, so here we go with the upcoming events. Usual things, I didn't really highlight anything as more spectacular than anything else because everything's good coming up this month. Another nice 4% moon and 4 degrees from Venus coming up on the 19th. We've talked about the Titan transit on Titan shadow transit on Saturn last few months. Well, now we're getting into the Jupiter double shadow transit seasons, one coming up on the morning of the October 20th. Rhine meteor shower. The Antares will be above the moon August 24th at dusk. That's probably the last month we'll see that happen for this year. Couple of occultations coming up on October 27th in the evening and October 30th in the evening with stars in Sagittarius and Capricornus. Daylight savings time, that's, well, either good or bad. You get to start observing an hour earlier, but when the sun is going down at 5 p.m., that's not too much fun. November 5th is the closest full moon of the year. Don't need to say anything more than that. November 9th, in the evening, Pollux and Gemini, Jupiter and Moon will form a nice little triangle. And then on November 17th, someone's birthday, the peak of the Leonid meteor shower.
Yay.
Thank you, Joyce. A few images from Angel, the Titan shadow transit back on September 20th. What I'd like you to note here, my mouse will work, you can see the shadow. I think this one, the top one, is a shadow, and the dark blob underneath it, that's Titan. Although actually now that I look at it, yeah, I don't know. I think that's correct. but we'll probably talk about this since Eric and Fischer and I saw this visually through the Bashir scope. Dave Rager has the spaghetti with no meatball nebula. Joey has a nice M51 image. Pat has a nice full moon with colorful clouds. Pat also has a movie of some solar prominences. Hopefully you can see this playing over the live stream. And then from the morning of September 19th, I believe it was, the moon and Venus were real close together, and depending on what time you were looking, Regulus was in a straight line. By the time I saw them a little bit later, the moon had moved, so it was a little bit more of a arc. And that brings us to other observations. This is I think the last time that we'll mention the Titan shadow transit, since the series ended on October 5th, ended for the next 14 or 15 years. Anyone want to make any comments on the Titan transits?
Eric Fischer would like to make a comment.
I thought he might. Go ahead, Eric.
He's coming up to the computer.
No,
Don't
I've
trip on those
hogged
extension
a
cords.
lot of time, and I very quickly, John. John and I tried to, when we saw the transit, we tried to do a high five, but it was dark and we missed. Okay. It makes all the work we've done at Wagner worthwhile to see this shadow forming on Saturn, all this drudgery and painting and scraping. So instead of waiting till 2039 for the next Edge On event and next shadow transit, let's set the next goal when the ring starts to appear above the limb of the planet. So I'm going to find that out. What day we can shoot for when the whole ring circumference of the ring is visible.
Okay.
The one thing I will add about the Titan transit, and Angel's photo showed that quite well, that Titan and the shadow were very close to the pole of Saturn. Well, the last event, this is from a member in the Delaware Valley Astronomy Association, on October 5th, the shadow just grazed Saturn. You can see it here at the bottom of the limb. But Titan, what really surprised me is Titan was very far away from the pole. And I thought, is this correct? Or is this guy did he just put random dots on Saturn and claim to have actually photographed it? Well, I looked it up in Stellarium, and sure enough, the September 20th, Titan was very close to the pole, almost grazing the pole. But on October 5th, Titan transit, this is Titan here, was further from the pole, closer to the rings. I thought that was pretty interesting. How about the comets? I know Dave Pensenstadler and Eric Bauer were talking about Comet Lemon before the meeting started. Either of you want to talk about your observations, or has anyone else seen any of the comets?
This is Dave. I looked at Comet Lemon about 4 o'clock in the morning the other day, and it moved so fast that in 5 minutes it was a long streak. And almost the same thing with Swan, Comet Swan. I took a picture of it tonight and didn't see much of a tail. But after 5 or 7 minutes, you could see it's becoming a line in a coma.
Okay.
So that's my observation.
All right. Thank you, Dave.
Yeah, this is Eric Bauer. I've observed lemons several times. It's easy in binoculars. Did look at it once in my 6-inch. Didn't look much different, only a little brighter than in the binoculars. It's clipping along. When I first looked at it, trying to think, about a week and a half or so ago, it was in Lacerta. And now, it's, in the back legs of Ursa Major. And in fact, oh no, yeah, it's gonna go into the evening sky sometime soon. I think by the end of the month, it'll be above Arcturus in Buttes. Yeah. I've
Yes.
tried for Swan twice, but as I mentioned earlier, my southwest sky is looking over top of downtown Pittsburgh. And through all of that atmosphere, because it's not very high up.
Right. Right. I do have one other observation to report. At the last month's meeting, I said that on October 9th, meaning last night, the Pleiades would be hard to see because the nearly full moon would be occulting them. Well, at about 11:40, I remembered to go outside, so I took my 7x35 binoculars and went outside, looked at the moon, but I couldn't see any Pleiades. So I was looking around, I was thinking, well, maybe I made a mistake. Maybe the moon's not as close as I thought it would. So I was looking around the sky, trying to find it. And I took out my app and looked at Stellarium. And Stellarium showed that the moon was just starting to occult the Pleiades. So I looked closer, and with a lot of effort, I was able to see a couple of faint stars near the moon. So the occultation was in progress. And another member of the Delaware Valley Amateur Astronomers took this composite image. I really don't even know how he was able to get so many stars. Of course, it's a combined very short exposure of the moon and a long exposure to get the stars. And that's probably why you can see this bright halo where the moonlight was interfering during the long exposures. And he just placed the burned out image of the moon with the short exposure of the moon. So this was probably a couple hours after I was looking at it. But did anyone else go out to look at the Pleiades occultation last night? Or sometime overnight this morning?
No one here in the live audience. I did go to work this morning. I did look up, but in all honesty, I did not look for that. But it was super nice and clear this morning. I will say that. It was really nice.
Maybe Phil was out somewhere, but he's not in the meeting.
Right.
Mhm. All righty. Does anybody else have anything to add? All right. Okay, we'll go ahead and move on then. Thank you, John. Much appreciated. All right, so we'll go ahead and talk about officer reports. Just looking at my list. Ooh, what happened there? Sorry about that, guys. There we go. All righty. Trying to see who all is on tonight. John Weskovich, do you have anything to report for the general meeting tonight?
Nothing that you haven't already heard from Rich's minutes update. The January and the March meetings are still available for anyone who wants to give a presentation. Otherwise, I'll find somebody external.
Okay. Sounds good. All right, I'm trying to see who else is on tonight. Rich, did you have anything for recording?
Nothing from the recording secretary.
Okay, did you want to give an update for like VA and offsite?
Just for the VA, like I mentioned, Tuesday, the 14th, we're going to try to do a star party. It's looking like it's going to be partly clear, so we're hoping for the best. Bethel Park Star Party is tomorrow night, and what originally looked like a good night is rapidly degrading, so check for an update tomorrow. I'm going to try to have it, but we'll see. And then only a couple more library parties. Chartiers Houston is the 28th. And we have a Peters Township Library somewhere in the 20s. I don't remember the exact date right now. That's it.
Okay. All right. Did anybody have any questions in regards to the VA news and also offsite for Rich? Okay.
Rich, they don't care. I didn't get certified as a volunteer. Nobody cares, right?
They'll report your shows on.
All righty. So go ahead, moving on here. I don't see Terry Mealy on tonight. Gail is on. She did send me the message for the new members. I know the only thing she had reported before was she is busy doing membership renewals. And again, if you guys have any questions or if you need to check on your renewal status, please email the membership secretary at 3ap.org. All right, trying to see who else. Liz, she is not on tonight. She reported that she didn't have anything to report and everything was going well on the social media end. Trying to see. Joyce, you are on for Guide Star. Do you have anything to report?
Well, I'd just like to express my appreciation as the Star Party season winds down to all of those people who have written reports on various events, especially the off-site Star Parties, and in particular, those who have taken pictures at Star Parties, and particularly the off-site Star Parties, because I can't, or Eric can't get down to all of them, so we appreciate having that. We did get down to the one in Bridgeville, which reminds me, I took a photograph of the sign on the building that said Bridgeville Library. So if you're on an off-site Star Party, if you could take some kind of identifying photograph, that would be helpful, so we can say, so they don't look just like every Star Party with telescopes in front of a library or something. If there's, or in a park, if there's some sign that you could take a picture of, so we could document that was that particular Star Party, we'd appreciate it. That's all I have.
Your mouse keeps getting stuck. Said I keep getting your mouse stuck. Oh goodness. See, every time. All right, there. All right, I'm not touching the mouse anymore. All righty. Okay, so I believe that's all who's online officer-wise. John Stump, did you have anything for Discord that you needed to mention during the meeting? Okay, thank you. What's that? I didn't forget that part. Shame on me if I ever would, right? All right. I was gonna say, I saw Heather was, oh, there we go. Heather joined back on. I know Eric is here. Did you want to come back up or have Mike come back up? Mike, it's your turn. He's like, no, Mike was like, no, I'm just gonna sit in the chair. I'm good.
Again, my apologies for hogging so much airtime tonight. Star Party's tomorrow at Wagman, and I think the 27th. And then we have one on November 22nd, which is getting late into the season. But the value is we might be able to, if you stay late enough, look at the Orion Nebula. We're on our last major repair to the building and the site, which is a new drainage system on the north side. We got the contractor approved through the county and the executive committee. And I keep reminding the Wagman committee, guys, we get done with all this grunt work, painting and scraping and wood repairs, we can start doing the fun stuff, electronic gadgets and all that, which is why we're in this club, not to renovate buildings, but to have fun with astronomy. So I've got a really talented group of people. I like to think that it could be a company, a consulting firm, you know, observatories are us. Okay, so thanks to all those guys. Jody, I'm not sure if you're out there in the world tonight. If you have anything, Mike, I guess you have no other comments to make?
Eric, I was gonna say the 25th, not the 27th.
Okay, yeah. Right, 25th is the next, tomorrow and the 25th at Wagman. And as always, we need help with parking.
Eric's
And-
never been good with numbers.
Very good.
All right.
Yeah, there was none in the presentation.
Anyway, that's it. Thank you.
Yeah, do not, okay. All right, thank you, Eric. Heather, I saw you rejoin back on. Are you able to give a report for Mingo?
Yeah, are you guys able to hear me okay?
Yes, we can definitely hear you.
Okay, awesome. Not much to report. The next star parties this month are October 17th and 18th. As a reminder, the theme for the month is the moon. So if anyone has any great YouTube videos that they want to share with me regarding the moon, I can add those to our educational area in the 10-inch ante room for the public to view. And most importantly, with the weather getting cold, it's time to start brushing up your chili skills. So start making your chili recipes and testing it out and perfecting it, because November 15th, we will have our annual chili cook-off with, the award awarded for the best chili. So if chili's not your thing, there's also the side dishes or cornbread, any of that kind of stuff is always appreciated. That's it.
All righty, thank you, Heather. Does anybody have any questions for either observatory directors? All I hear is crickets. Okay, I think we're good. All righty, so going ahead and moving on. Trying to remember, so old business, last month was the first, it was the first general meeting kind of after the summer. I know we were talking about dates for the astrophoto contest. Again, Rich had gone over those dates with the recording meeting minutes. John, did you want to give any updates on the astrophoto contest? And again, we are going to be having the meeting at Allegheny Observatory. So next month, we will not be at Mingo. We'll be at Allegheny. But yeah, John, do you have any updates for that?
No updates per se. The October Guide Star has all the information. I have received submissions from 2 members that I will be, haven't confirmed with them yet that I received them, but they are coming in and I will be working on them probably this weekend to start to get the project going. If anyone has any questions, feel free to unmute and ask away.
Just out of curiosity, what was your deadline to get the photos in?
The deadline is, let me check this, I believe it was Halloween, but let me, what year is this? 2025. Yes, the deadline is October 31st.
Okay, thank you. All right, does anybody have any questions for John?
John, will you be doing all online voting so that for the November, we'll have the winners?
We'll have the winners after November 15th, because we'll also be doing in-person voting at the meeting and online voting.
Okay, so we are doing the in-person voting as well. Gotcha.
Yes.
Okay. All right, sounds good. Okay, trying to think what else. The holiday party, again, we talked about that in the recording meeting minutes. That is Friday, December 12th at the Buffalo Inn, South Park or Bethel Park? South Park, okay. If you have any questions, are we, since we're doing potluck, I don't think we started a spreadsheet yet for food sign up. Heather, do you know it? Were we gonna do one this year? Since Mingo's the one that's hosting it?
I'm sorry, what was the question?
For the potluck, are we doing another spreadsheet sign up, like we did last year?
We can do that for sure. I know that people still are, welcome to bring whatever they want, even if it is a duplicate. But I think the spreadsheet kind of helps, prevent some of that. So yeah, we can get a spreadsheet together for that.
Okay, sounds good. Thank you, Heather. I'm sure more to come as we get closer. I know it's going to sneak up on us pretty fast, for 2 months, but just some, give us ideas. You can email myself or any of the Mingo directors or any of the Mingo committee as well too. And if you have any suggestions or anything for the holiday party, let us know. Another thing, so yesterday evening, we had an executive meeting. So we also had a discussion of the holiday party. So I did put out that if anybody wants to donate any equipment or literature, anything for the door prizes, you are more than welcome to bring items to the holiday party if you would like to donate them. Obviously, we do ask that it's, of course, astronomy or science related equipment, anything that you're bringing is in good condition. If you have questions, whether or not that if something is okay or not okay, feel free to email me. If I don't know the answer, of course, I'm going to ask somebody. So I'm just putting that out there. But, we did have a really nice turnout last year when Wagman hosted. We had a really great turnout of people. So, of course, it's getting cooler outside. Maybe people were, going through their closets or their garages and I don't know if I'll use this eyepiece anymore. Or, I've had this book for a while. But anyway, if anybody wants to donate anything for the door prizes, please let me know. It would be greatly appreciated.
Kristen, in the old days, the only stipulation, no counterweights.
No counterweights. All right. Good. Well noted. Well noted. Heather, did you have something?
Yeah, I just wanted to also add that for, members who are volunteering their time at star parties, some people may not think to go and sign the member sheet that you were volunteering at the star party. As a reminder, if you do 5 or more events for us, you're eligible for a volunteer gift. So just please make sure that, you're signing those sheets and you're recognized for those star parties when you volunteer.
Okay. And also, I do believe in the discussion, we did include offsite as well too.
It's any event. So, the Spaceberg, Allegheny Observatory, it's inclusive of all events.
Okay. Yeah, thank you, Heather. Yeah, please let us know. Gail has been doing a fantastic job with keeping a spreadsheet with members that have been attending star parties and also offsite. So if if you believe you may have missed your sign up on something, you could probably email her and she could update that spreadsheet. So yes, well noted, well noted. But anyways, okay, I think that's all I needed to report on the holiday party. So more news to come on with that. Another thing that I wanted to mention tonight, again, we did have, like I said, an executive meeting yesterday. One of the topics, and it was a very short discussion, we never came to a conclusion, but it was kind of a start of a topic. So as you all know, for this year, the observatories and also for prior years we've been doing a lot of projects, very good projects, a lot of nice updates. We've had a lot of maintenance that has needed to be done with the observatories, repairs. So obviously the club, of course, we are providing those funds to make those repairs and those updates. What we are maybe considering, and like I said, this isn't a final decision, we are possibly considering raising the dues for next year. It has been over or around 10 years since we've raised dues. From what we can see, we're probably one of the few clubs that have our dues as low as we have for individual and family. So I just want to kind of let you know that this is something that is in discussion. We did not vote on anything. Obviously, we feel that we want to keep progressing and we want to provide equipment, education, also through our outreach. We want to keep providing those resources, and we just want to make sure that, of course, we have the funds for that. So more to come. We'll let you know. And again, we just wanted to keep you informed. So if you have any questions or any concerns, you can definitely feel free to email me. And, of course, I'm always open ears. So, all right. Okay. Moving on. I'm trying to think if there was anything else on there, but I think I covered the majority. I know we just had Spaceburg. I believe everything from the feedback that I got, everything went really well. I know Gail and Patrick don't have sound on their computer. Was there anybody else online that attended that event? Angel did. I think Angel's online, right?
Hey guys, yeah, I did. It was really cool. We had members that brought 3 telescopes there. We had quite a crowd, so we were able to show clusters and the moon and Saturn to quite a few people. So there's so many people who were interested and distributed a lot of materials, and it just in general, people are very, very interested in knowing about the club, knowing about astronomy and the Allegheny Observatory, so I had a lot of fun. It was pretty cool. So
Nice. Wonderful. Thank you so much for the update. Joyce, you had your hand up?
Well, I just wanted to say that I was volunteering at the Moonshot booth, and I saw a very large, obviously, TV camera trained on our telescopes at the AAAP booth. And then when I got home and looked at, yes, okay, Patrick says KDKA, because yes, I saw their report on the 11 o'clock news, and over the weekend showed people looking in our telescopes as like the major part of the clip for Spaceburg.
Nice. Very nice. It's, I know, was it KDKA that came up to Wagman was it for the meteor shower last year? Do you remember? You got,
It was on a Star Party.
it was,
Several years ago, David Highfield.
no, I think it wasn't you
It was
and,
a couple, it was last year.
yeah, last year. I was gonna say, because
But you're also a couple years.
I was gonna say,
For the Aurora in October.
that's what it was.
The
Yes.
KKA channel, actually, all three of them, I think, did something. At least I remember Channel 4 and Channel 2 actually interviewed. I think Channel 4 just took footage.
Okay. All righty.
Kristen just mentioned that we had a very good AAA turnout at the open house.
Oh, okay.
12 members showed up.
Okay. I don't know if you all could hear Eric. Eric said about 12 members showed up at the Allegheny open house. And that was also very successful. Sorry, I was looking at the chat. Here, let me go back here. I see Patrick's or Gail, someone's doing a lot of chatting. The guy from KDK was given a message just an hour before he arrived to go to Spaceburg. He didn't know what it was all about. So I guess he got a big surprise when he got there, or at least educational. All right. Anyway, I think that's all I had to report tonight. Does anybody else have anything that I might be missing?
Nomination for awards?
Oh, yeah, that's going to come in November.
Okay.
Yeah, because then the awards would go out at the holiday party. Okay. Rich Dolish just brought up about nominations for this year's volunteer awards. So I believe we're going to have that discussion at the next meeting. I might send something out earlier than that just to give everybody some time. But just remember that general membership can submit nominations for those awards. And, you know, again, just go ahead and email those nominations to myself. Last year we had a lot of nominations. I will say that. It was very overwhelming, but very well deserved for those individuals that did receive the award. So maybe what I'll do is I'll send an email out with the members that did get awards last year. And then those of you who want to submit a nomination or nominations, just send them back. Okay?
We're going to have way more this year because of that.
Yeah. Okay. All righty. So if there is nothing else, may I get a motion to adjourn the meeting? I see all the hands. Rich had his hand up and John also had his hand up. So I'll take that as a first and a second. All those in favor, would you like to give a thumbs up or an aye? Aye. All right. Are there any objections? Are there any abstains? All right. Thank you very much, everyone. Sorry again for the PowerPoint like oopsies that we kept having, but I'm glad we got that resolved. Hopefully I'll have all the IT support needed at Allegheny, John. So we'll be good to go. John Stump, or do you think, are you going to be at Allegheny to live stream it there, or were you just going to not be on location? Okay, sounds good.
Yeah. The 14th.